So example 2, using Buckingham Pi Theorem, show that the velocity through a circular orifice is given by v is equal to square root of 2gh is a function of diameter over h and viscosity over density times velocity times h. H is head causing flow, g is diameter, then mu is coefficient of viscosity, and rho is mass density, and g is association to gravity. We can tell here that for this question, we have that question is a function of velocity, then we have the head, we have the diameter, we have the viscosity, we have the density, and we have the gravity. So basically, there are 6 physical quantities here. Let's put out the dimensions for these quantities now. For velocity, it is Lt minus 1. Again, for the head, the dimension is L. For diameter, the dimension again is L. Well, for the viscosity, the dimension again is M, L minus 1, T minus 1. Again, for density, the dimension is ML minus 3. And lastly, for acceleration, the dimension is LT minus 2. So let's begin now. We can say that in all of this, we can see that there are 3 basic quantities here. So our M is 3. So how many? We have 3 repeating variables. So the repeating variables, to select the repeating variables, as I look at this question, I realize that there's a g here, there's a h here. This h must have been with the velocity. That tells me that h was selected. Well, h is geometric property actually. We have to, in our geometric property, we have between h and d, but h is selected. I can see that here. Again, our flow property, we have that g was selected. And so lastly, we have our fluid property. For the fluid property, we have viscosity and density. And obviously, if you have viscosity and density, we take density. So these are our repeating variables. So understand that we are choosing this based on the fact that I could see this. If you look at our previous question also, we realize that this is attached to dependent variable actually. We only put it here. So I know that G and H was selected for this question. So it just remained density and viscosity, and I have to choose that. So this is my geometric property, this is my flow property, and then this is my fluid property. The next is that how many pi term we have here? There would be n minus m pi term. That is 6 minus 3, which is 3. So the next thing here is to get the pi terms. Now let's get pi 1 terms. So for the pi 1 term, we have that pi 1 is equal to h raised to power a1, g raised to power b1, and density raised to power c1, then times our dependent variable, which is b. Now this is m raised to power 0, l raised to power 0, t raised to power 0 is equal to, this is l raised to power a1, g raised to power b1, and the dimension for g is lt minus 2 raised to power b1, and then density is ml minus 3 raised to power c1, then times velocity lt minus 1. So this is what we have now. Let's simplify further. M raised to power 0, L raised to power 0, T raised to power 0 is equal to L raised to power A1 times L raised to power B1 times T raised to power minus 2B1 times M raised to power C1, L raised to power minus 3C1 times LT minus 1. Again, this will be M raised to power 0, L raised to power 0, T raised to power 0 is equal to L raised to power A1 plus B1 minus 3C1, then times M raised to power C1, then times T, for the L, there's a plus 1 because of this, plus 1, MC1, and then T now, minus 2B1 minus 1. So let's compare now. For the M, we have 0 is equal to C1. That is basically done. Then the next is for the T. So 0 is equal to, for the T here we have minus 2B1 minus 1. So this we have minus 2b1. So we can say that b1 is equal to minus 1 over 2. Okay, the next is for the c now. For the L. So for the L, we have 0 is equal to a1 plus b1 minus 3c1 plus 1. So this will be 0 is equal to our a1 here. We're looking for that, but our b1 is minus 1 over 2 minus 3c to 0 plus 1. So this is equal to a1 plus 1 over 2 minus 1 over 2 plus 1 over 2 will give me plus half. So simple, a1 is equal to minus half. So we can come back to say that our pi1 term is simply equal to h minus half, then g, putting the values here, g, again, minus half, then density raised to the power 0, then times v. So this will simply give us v over h half and g half. I will know what half means, square root now. So this is equal to v over square root of g h. So that's that about this. Let's take the second one now, pi2 term. For the pi2 term, we have that pi2 is equal to, again, h raised to the power a2, and then g raised to the power b2, and then density raised to the power c2 times another variable. Let's go with the diameter d. So this will be equal to pi2 m raised to the power 0, l raised to the power 0, t raised to the power 0 is equal to our L, our H is L, A2, and this LT minus 2 for our G, B2 times the D now. Our D is, okay, density first, M, L minus 3 raised to the power C2, then times our D. The D is dimension for D is L, so L. So we can now go, so we can simplify that further. This is the m raised to the power 0, l raised to the power 0, t raised to the power 0 is equal to, let's begin with L now. Since we started with L in the previous question, A2 plus, on that L we have here is B2 plus B2 plus again, on that L we have here is minus 3C2. So minus 3C2, then plus, what else again? Plus 1. Then we have our M. Our M is just C2, and then again, our T is just minus 2B2. So we can tell from here that let's compare M first of all. We're comparing M now. 0 is simply C2. That is gone. Let's compare T now. We can tell from here as well that 0 is equal to the power of T is equal to minus 2B2. So simply B2 is equal to 0 as well. Let's go for our C. We can say from here that L, let's compare the L now. A2, 0 is equal to A2 plus B2 minus 3C2 plus 1 is equal to A2 plus 0 minus 3 times 0 plus 1. So this is A2 plus 1 equal to 0. So simply 8 is equal to minus 1. So we can say our pi2 term now is equal to, our pi2 term is equal to h raised to power 8, which is minus 1, and then g raised to power 0, density raised to power 0 times d. This will simply be d, because everything here will give us 1. This will give us 1, d over h. That's the value for this. Now, the next is for our pi3 term. For the pi3 term, we have pi3 is equal to, again, h, a3, then l, h, and the next one is g, b3, and then the next one is density, C3 times what we have there is, we've compared I think we have viscosity left. So this will be m raised to power 0, l raised to power 0, t raised to power 0 is equal to l raised to power a3, lt minus 2 raised to power b2, then m l minus 3 raised to power c3 times viscosity m l minus 1 t minus 1. Okay, so let's compare so fast here. We have it that, let's compare m first. Power of m here is 0, while the power of m here is m is c3, because this m will carry c3, and then plus 1, the power of m here. We can tell that c3 is equal to minus 1. That's settled. Next one is for the t. Let's compare t now. This 0 is equal to compare t, what's the power of t here? 0. What's the power of t here? That will be minus 2b2, yeah, and then minus 1 again. So we can tell that b2 is equal to minus 1 over 2. Now let's compare for t. For t, this for l, sorry. For l now, the power of l here is, the power of l here is 0, while the power of l here is a3, yeah, plus b2, yeah, minus 3c, 3, yeah. This is b3, please. This is b3. This is b3, please. This is b3. Minus c3, and then minus 1. That's L. So we can say 0 is equal to A3. Our B3 has been gotten to be minus 1 over 2. Then minus, our C is minus 3 times minus 1. And then plus minus 1 again. So this will give us A3. This minus 1 over 2 plus 3 minus 1. This will give us 3 minus 1 is 2. 2 minus half will give us 3 over 2. So we have A3 to be minus 3 over 2. Hence, we have our pi 3 now is equal to h with A3 minus 3 over 2. And then times, we have our g B3 to be minus 1 over 2. And then we have our density to be minus 1. And then this is viscosity. So this will simply be viscosity over h raised to power 3 over 2, then times g half, then times density. So this can be mu, yeah, all over, okay, density, yeah, h times h half, then times g half. So if you combine this, you get 3 over 2. This will be simply be mu over density h, then times square root of gh. I want to bring out something here. I want to put v here and put v here. This will become mu over density h, v, put v, v. I put v here, put v. They can cancel out at the end of the day, which brings us back to what we have, the square root of gh. I'm simply doing this because I can see my pi 1 is here. So this becomes that pi 3 is simply equal to mu over density h, and then density h v times v over root gh. And this is pi 1. We've said that this is pi 1. So it means that pi 3 is simply mu hv times pi 1. We can now say that f1, pi 1, pi 2, and pi 3 is equal to 0, which is f1 into what's our pi 1? Our pi 1 is v over square root of gh, comma, pi 2, we got that to be d over h. Again, we have that pi 3 is equal to mu rho hv times pi 1. So we can tell, let's look at our question again. Let me go through our question again to see, because we have to prove here. So we don't just solve. Okay, so that's that. We can say F1, we can say V over GH is equal to, we can write like this, D over H, then mu over, so I'm moving the constant now. Let's put pi 1. Okay, we can bring this here. V becomes square root of GH phi into, I can choose, since we have to prove, I can just introduce any constant. You can introduce constant and you will remove constants here. This will give us d over h, comma, mu over density hv. That's all. Meaning that as we write this, we remove every constant we have, because this is a function of this. We are removing the constant. Constant is leaving already. If this was to be equal to, that's when I will put it. But if you're saying this is a function of this, then I should remove the constant here. And we want to prove something. Where is this 2 coming from? Well, because we have to prove, we can introduce whatever we want to introduce here. Any number we like, we can put any number we like into this. That's why we are putting this 2 here. So that's that for this question. We are done proving what we want to prove. You can introduce constants here, any number you want to introduce. So that's that about that for this question.